First thing we're going to do is we're going to change the title of this section. Take out the word graphically, since we're not going to be using our graphing calculators. We are going to call this one the general solution. And what that means is, you know how we've solved a lot of our equations between 0 and 2 pi? And sometimes you've solved them between negative 2 pi and 2 pi? Well, now we're going to say, what happens if we just said, solve it everywhere? What would our answers look like? So that's the only thing that's new in 7.1, is we're going to solve the same equations we've solved before, but we're not going to restrict the domain from 0 to 2 pi. So what I'd like you to do is, on page 572, we're going to skip this getting started and skip the construct the understanding, and I've made my own warm-up. And it's going to be a review of stuff we've done in chapter 6. So can you solve for theta between 0 and 2 pi? And so you can write this, start on the 572, and you can work on the column on 572, and then there's going to be space on 573. So between those two pages, I'd start here. Start on the top of page 572. There's going to be 4 questions for warm-up. Here you can see the first 2. All right. So did you get a reference angle of 0.73 for the first one? And then, because sine is negative, you would find answers in quadrants 3 and quadrants 4. All right, there's the second one. All right, check on this one. You get your reference angle will be 0.359. And quadrants 2 and quadrants 4, because tan is negative. Next ones are non-calculator. Okay, so you got cos theta equals 4. That's not on your pi plate. But cos means what over what? Adjacent over hypotenuse. So the adjacent is 4. Your hypotenuse would be 1. That's not possible. And that's why you can do it without your calculator. And now, in part D, I'm going to introduce to you what we have in this section. So we're going to start by solving this normally from 0 to 2 pi. And then we're going to look at what does it mean if you say the domain is everything. So this one was in quadrant 2. So I would go pi minus my reference angle. And then 2 pi minus your reference angle for that one. All right, so starting off, get tan by itself. And then a little bit of difficulty here because on our unit circle we wrote root 3 over 3. Do you remember that root 3 over 3 is the same as negative 1 over root 3 if you rationalize the denominator? So sometimes in an algebra question it comes up in that other form. You still have to be able to recognize it. So that was the first part in this one that maybe adds a little bit of difficulty. What family is this? My pi over 6 family. Tan is negative, so you're looking in quadrants 2 and 4. So this would have been chapter 6. Solved it between 0 and 2 pi, you are done. Now, chapter 7 actually combines two ideas from chapter 6 together. The first idea is solving between 0 and 2 pi, which we did already. The second idea, which you had on your quiz, is coterminal angles. So, if we take out a unit circle and say one of the answers is 5 pi over 6 right here. That's in the first time around, you'd hit 5 pi over 6. If you were allowed to go 2 times around, you could add 2 pi to that and get to it again. If you're allowed to go 3 times around, you could add 2 pi again and get to it again. And so, in order to solve the general solution, we take the answers that we have, which is 5 pi over 6 and 11 pi over 6, and if you write all the coterminal angles with those, you will find all the solutions. So the format for writing it is saying theta equals, and then you just write coterminal angles of everything for each one. And we have a squiggle bracket, which is fancy. You add 2k pi to both of them where k is an integer. Yes? Yes. Yes. So in the diagram here, so what Spencer is saying is I could have done, and the green ones are showing the 5 pi over 6. The red ones are showing, well, since it's only halfway around the circle to get to 11 pi over 6, he's saying, couldn't I write instead 5 pi over 6 and then add pi and add pi and add pi and add pi, and that would hit both of them forever. So yes, in this situation, you could combine both of those answers that I have here like this, and it's a little bit more elegant because your answer is shorter. That only works with tangent, because tangent's the only one that's in quadrant 1 and 3 or 2 and 4. So tangent is the only one which skips by pi. It won't work for sine and cos. So a lot of people just decide to use this method. I'm going to find my answers between 0 and 2 pi, write them down, and add 2k pi. And even though this is more elegant as an answer, the other one would be accepted completely right. But we will look at what is more elegant. And sometimes in multiple choice, they have the more elegant answer listed for a tangent question, so then you'd have to be able to recognize it.